Hi there, I'm Hao. This is just another video of me solving random numerical problem. So given an integer array of length n and an integer target, we need to find three integer nums such that the sum is closest to the target. So the difference between the sum and the target is had to be as close as possible, right? So the difference between the absolute value, right, of the difference between the sum, right, and the target has to be as close as possible, right? So the closer to zero, the better, I think. Right, if the difference is zero, which means they are the same, right? The exact sum. So we can try all combination, right? Using a brute force approach, but it give it a very bad runtime. But if we can short the array, right, then we can use the two-pointer approach to do this. We give us a better runtime of O n cube, right? Plus n log n for shorting, but we can ignore this, right? Sorry, O of n square plus n log n. So it will improve our runtime by a little bit. And I assume that the pre-integer will be unique, right? So we can start I here. We can keep track of our current sum. So our current sum, right? Our current difference, and our minimum difference, right? And our closest sum. So our current sum. So we need our left and the right pointer, right? Moving left and right to make sure we are closer and closer to the target. So the left is always one spot, one index after the I, and the right pointer will be always be at the end. So our current sum now is -5 plus 2 is -3, right? So the difference between this sum and the target is 4, right? At a minimum difference, we can start at our closest sum at infinity. So our minimum difference is the difference between the target and the closest sum, right? Which is infinity. So because we found a new minimum, right? So we update our closest sum to -3, right? And update our current difference to 4, right? And because -3 is smaller than the target, right? We have to move to the right to find a larger number so we can get closer to our target. So the sum now is -1, right? The difference is 2. And the minimum difference will be is 4, right? And we found a new minimum, so we update our minimum difference to 2, and we update our the closest sum to -1. Okay, and now -1 is still smaller than 1, so we increment our left, and now they are overlap. So we exit and increment our I to the next pointer. We set up our left and our right pointer. So the new sum now is 3 minus 1 is 2. The difference is only 1, right? 2 minus 1 is 1. So we found a new minimum. We update our minimum difference, and we update our closest sum to 2. And that's pretty much it, right? Because we only iterate I to the length -2. Because we need to leave space for the left and the right pointer. And we only look at 3 elements at a time. So we can return our system with the output here. The space complexity would be without the sorting would be constant, right? But it will depend. With the sorting, it will depend on the sorting algorithm, either log n or O of n. So we need our closest sum equal to infinity. So it always pass on the first comparison. And we can return it at the end. And we don't have to worry about the nums only have less than 3 elements, right? Because we have the constraint here. We know that nums array, we have at least 3 elements. So we always have a result here. There's exactly one solution. So we need to sort it first. The nums equal nums of sort. Okay, so we need to iterate through the nums. Okay, and we need to have our left and our right pointer. Left is 5 plus 1, and right will be the last one, right? Nums of 9 minus 1. And y, left is less than right. We can calculate our current sum equal to nums of I plus num of left plus nums of right. And we can calculate our current difference. It's the absolute value of the target minus the current sum. Right. Our minimum difference is also the absolute of the target minus the closest sum, right? The closest sum. Okay. And if the minimum difference, the current difference, right, is smaller than the minimum difference, then we found a new minimum, right? So we want to update our closest sum equal to the current sum. Current sum, right? And now we need to update our left and the right pointer, right? If our current sum is smaller than the target, we update our left pointer. We move to the right side. And if the current sum is smaller, that is bigger than the target, right? We need to move to the left side by update our right pointer. So if current sum is less than the target, we have to move left. Otherwise, we need to move right. So we need to move right. Otherwise, we need to move left, right? And I think that's pretty much it. Let's try that. And thank you for watching.